is a video for Reactivity Series of metals. So what I'd like you to do while I'm doing this experiment is you need to be filling in your table, which is your worksheet. You need to be writing down observations. So you need to be using descriptive words to describe what you can see, and you need to be able to decide which one is the most or least reactive. Now, first thing we're going to start off with is we've got some group 1 metals. So we've got lithium, potassium, and sodium. So these are our dangerous metals. You can tell they're dangerous because they've got the sign for flammable on them. They're also oxidizing agents. This means they react violently with oxygen in the air. And this is why they're in these tubs filled with oil, so they don't react. But they are still reacting with small amounts of oxygen, so you can see that because it is white. Metal isn't usually white, it is usually shiny and silver. So we're going to start off with some lithium. Well, first of all, we'll have a look at how they all cut. So, starting off with lithium. So, lithium, you can see, is a silvery grey metal. It's quite firm to touch. If I cut it with a knife, it's quite hard. It's like cutting, slightly harder than cutting chocolate, I think. Fridge chocolate is what it's like. So that's all lithium. So I'm just going to move that to one side here. We've got potassium. Get some of these out so you can see. Potassium is a silvery grey colour. I'm going to cut it with a knife. And you can see it's very easy to cut. It's a bit like cutting, I imagine cutting blue tack with a knife would be like. That's how I'd describe it. The final metal that we're testing is sodium. So in this one, you can see it's a very white metal. So with sodium, I'm going to cut it, and it's slightly firmer than potassium. It is quite cold in the school today, so that could be one of the reasons why. So, next thing we're going to do is we're going to put them into water. So on your sheet it talks about reacting them with acid and water, but because these are super reactive metals, we're not going to react these ones with acid, so we don't want to blow up the school. So we're going to react them with water only. Now, here we go, we've got a big load of water. Now I'm going to put into this some universal indicator. Universal indicator will tell me the pH. So you can see universal indicator is green. Green means it has a pH of 7, which is neutral. So at the moment it is neither acid nor alkali. It is neutral. So first one, putting it in, we've got a piece of lithium. So you can see with lithium, it's bubbling quite vigorously. You can see the bubbles coming up. The large bubbles, these are bubbles of hydrogen gas. Hydrogen is an explosive. So we could actually catch some of that and do a squeaky pop test, which we will do in a minute. You can see it's not particularly clear on the camera. It's actually turning purple. So when I'm reacting it, it's turning purple, which means it is a strong alkali. So it has a pH of above 7. Right, on to the next one. So this one is potassium. So here we go, here it is. So you can see it burns with a purple flame. Ooh. So it burns with a purple flame, and we call it a lilac flame. And it has a little explode at the end. So I have to run away when I put this one in, so that's why I go a little quiet for a minute. So I'm going to do it again. I'm just going to zoom the camera out so you can get the full thing, because I can't follow it with the camera. I'm about to set myself on fire. So here we go. You can see it is a lilac flame. So in this case, it's so reactive that it is setting the hydrogen gas on fire. So hydrogen sets on fire, and potassium is used in fireworks. So fireworks, if you get the purple ones, that's when the metal potassium sets on fire. and it releases a lilac flame. Last one is our sodium. So putting it in. So you can see sodium forms a molten ball of metal that floats on top of its gas. You can see them over the far right hand side, the little specks that are moving around like little particles. Just staying away because they sometimes explode at the end. Right, so that is sodium. So you can see that one fizzed so vigorously that it formed a molten ball of metal that floated on top. It didn't set on fire, so it's not vigorous enough to set on fire. Now I'm just going to move this to the side. The other part of the experiment, which is in the table now, so on the table on your worksheets it says fill in the reactivity of different metals with both acid and water. So we're going to start off with water. So you can see here we've got our metals, our boiling tubes, so I'll just put them like this. There we go, and we can sort of see them a bit better. So I'm going to put into here the different metals and we'll see how they react. So again, you should be filling in your table during this time. So first one is copper. So copper is a metal that we use for wires. It's lovely copper colour, so like a brass colour. Put it into water. And you can see it doesn't really do anything. So copper is unreactive and we use it in our water pipes. So pipes around the school and around our homes, all are made out of copper. It does react eventually. You'll notice your pipes at home, if you've got an old house, it might be like a dark greeny colour. That's where copper's oxidizing, but it doesn't really react. Going for the next one. So in this case we've got some zinc. So zinc is a metal that's in most of alloys, so like copper coins, or I suppose in America where they have the nickel coins, it's where they use zinc and they mix it with copper and it turns a nice silver colour. So I'm going to put that in. You can see it's not reacting. Next one with water is our iron filing. So this is just an iron, like an iron nail. Now iron, as we know, forms something called rust, but it takes a long time. So we'll put some in and have a look and see. But you can see straight away it's not reacting instantly, because in order to do that you need it to be hot, you need it to be in the air. You need to leave it out on the side for a long time for it to react. Now the last one we got is calcium. So calcium is what makes up your teeth. It's one of the metals in that. It's in group 2 of the periodic table. I'm just going to put in a couple of balls. So you can see here they are actually fizzing, and the temperature of the water is going up quite a lot. So calcium fizzes at room temperature. Now if these were warm, we might actually see some bubbling from the iron or even the zinc, but because it's quite cold in the school today, like I said, we've got some slow bubbles. Right, we're going to have a look at reacting the same metals this time with acid. So this is in the column that says metals with acid. You're just going to be filling in that one next. Whoops. Okay, so it's the same metals, but this time with acid. So the acid that I'm going to be using is hydrochloric acid. It's 1 molar. Ooh. Hydrochloric acid is 1 molar. Okay, so that means it's semi-concentrated. I'm going to put in about a finger's depth into each, so it's going to be a little bit of a random amount. There we go. It's enough in there. Oops. A little bit in there and a little bit in there. We're going to do it in the same order. So the first one we used last time was copper. So put a little copper in. can see with this one, again, it's not really doing anything. So copper is a pretty unreactive metal. I mean, the main difference you can see, which you might not pick up on the camera, is the acid has actually cleaned the copper. So now it's a lovely bright brass colour, whereas in here it's quite dark. So not really very reactive is copper. So next one we're going to put in is our zinc. So zinc again. Try and find a good bit. So in there. So with zinc, it didn't react with the water, but you can actually see it forming some very slow bubbles from the acid. So it is reacting quite slowly. The next one is iron filings. So putting some iron into the acid. See what happens. So again, no bubbles, but there is there's some very mild bubbles, so they're even slower than the zinc, but there's a couple of bubbles going on there. It's hard to picture on there, but you can sort of see them. You see there's bubbles going up. There's also a smell because sulfur is present in iron as an impurity, so when I put acid in there it reacts and forms sulfur oxide, which smells like eggs. It's kind of disgusting. So that is reacting in there. You can see the bubbles. So just comparing the two. So it's going to be the one with the fastest bubbles moving that is the most reactive. So you can see, even though there's a lot more bubbles because this one's a powder, you can actually see that the zinc is producing more bubbles per second. Therefore it's more reactive. The final one, I'm going to make sure I'm only putting one little tiny piece of this in, is calcium. So here it is. Put it in. So you can see it reacts with the acid. It's forming a lot more bubbles, quite biggest bubbles at the bottom, more than zinc, more than iron. It takes a minute to start off because calcium, like the other metals, it reacts with oxygen in the air and it turns white as it forms calcium oxide. So you can see it's white, whereas calcium is naturally silver in colour. So one of the issues that it might not be reacting straight away is due to it having to burn away the calcium oxide, which is like a protective layer on the outside, a bit like rust, but rust only exists in iron. Now this is getting really hot, so I'm going to put it down. So in terms of what you need to do now, is you need to decide which one was the most to least reactive. You also need to fill in the table describing how they reacted with both water and with acid